So the latest work shows that imidazole propionate, or IMP, is not just a bystander, but actually a driver in atherosclerosis.
Yeah.
It's fascinating how they demonstrated that this metabolite from gut microbiota can directly induce plaque formation in the arteries, even without changing cholesterol levels.
Wow, really? So it's not, the typical lipid issue then?
Exactly. It's
Yeah,
almost
right.
like it's setting off an inflammatory cascade. The paper outlines that IMP activates both systemic and local immune responses, in particular, both innate and adaptive arms, triggering inflammation that contributes to plaque buildup.
So, does that mean the immune cells are the main culprits here?
Precisely. They showed that in mice prone to atherosclerosis, IMP administration increased inflammatory cells like Li6C high monocytes and T helper cell subsets, all without altering blood cholesterol or glucose. It's like the metabolite hijacks the immune system to promote arterial damage.
And how exactly does IMP do that? Is there a known receptor involved?
Yes, that's one of the most striking parts. They discovered that IMP engages the imidazoline 1 receptor, known as I1R, on myeloid cells. This finding activates mTOR signaling, which then ramps up pro-inflammatory cytokine production like TNF.
That's incredible. So if IMP uses I1R to worsen atherosclerosis, does blocking that receptor help?
Exactly, and that's the therapeutic twist. They used a compound AGN192403 to block the I1R, and it prevented the EMP-induced atherosclerosis in mice. It's almost like using a lock and key to stop the bad signal from being transmitted.
Yeah, that's a neat strategy. But, could there be caveats here? I mean, blocking I1R might have other systemic effects, right?
That's a fair point. The study does acknowledge that IMP might also influence other cell types beyond myeloid cells. So while the blockade looks promising, there might be off-target effects in a more complex human system.
And what about human data? Was there any indication that IMP levels correlate with early atherosclerosis?
Yes, indeed. In 2 independent human cohorts, they found that higher plasma IMP levels were strongly associated with subclinical and active atherosclerosis. They used advanced imaging to detect these vascular changes before overt symptoms appeared.
So it seems like high IMP could be a biomarker for early atherosclerosis, in addition to being a therapeutic target.
Exactly, it's a dual opportunity, both a diagnostic marker and a target for intervention. It's like, imagine having an early warning system that not only sounds the alarm, but also gives you a specific way to shut it down.
That's powerful. But I wonder, do you think the focus on the mTOR pathway might overshadow other potential mechanisms at play in atherosclerosis?
I get your concern, and it's valid. While the mTOR link here is compelling, atherosclerosis is multifactorial.
Sure, right.
The authors hint at, but don't fully explore, other systemic or cell-specific effects of IMP, so more research is definitely needed to see the complete picture.
Overall, though, this study seems to open up a new avenue for combined therapeutic approaches, maybe even synergizing with lipid-lowering treatments.
Absolutely, it paves the way for a personalization of atherosclerosis therapy beyond just controlling cholesterol. Targeting the gut microbiota metabolites and their receptors could add another layer to cardiovascular prevention strategies.
Fascinating stuff. It's like we're finally unveiling hidden layers in the development of heart disease.
Exactly. And with these insights, we might soon see a shift in how we diagnose and treat atherosclerosis, moving beyond traditional risk factors to a more nuanced, molecular-based approach.
Yeah, indeed.